Okay, back again. Today we're going to do some more adding and subtracting fractions, but this time it's with mixed numbers. Do you remember what a mixed number is? I can hear you. You're saying it's a whole number plus a fraction, right? That's what we call a mixed number, a mixture of mom and you, or dad and you, okay? A mixed number, whole number plus a fraction. So we're going to add and subtract those. So it's really just like yesterday, only there may be an extra whole number in there, okay? In fact, we even did this on the story problem, so I'm kind of surprised they're having us do this page again. But that's all right, because I'm sure we need the practice, right? Practice, practice, practice. They know kids are not going to get this all in one lesson. That's why we do it over and over and over. Okay, if you got it in the one lesson, good for you. Great, pat yourself on the back, and this should be easy for you then, right? And if you still don't have it quite yet, then that's why we keep practicing. We'll practice each day, so that gives you more and more time for your brain, for it to settle into your brain and your brain to remember. Just like that's what my brain feels like right now. I'm trying to figure out this Google Classroom thing and how to find you guys and how to make sure you guys can see it and how to find where you sent your paper in. And it's kind of confusing too. So that's just part of life. We learn all of our lives. More and more new technology comes out all the time, and you just have to go with it, and you have to learn stuff new all the time. So if you resign yourself to being a learner all your life, you'll have a much easier life. Otherwise, if you don't want to learn new things, you're going to be frustrated all your life. So take it with, yay, how can I do this? Look at it as a challenge. I can do this. It's hard, but I like to try to learn hard things, because then it makes me feel accomplished, like I've accomplished something, right? If you've worked really hard and you finally get it, makes you feel good. Okay, so we're just doing some more practice again. This says here, grandmother's bread recipe calls for 2 3/4 cup flour, white flour, 2 1 2/3 cups wheat flour. How much flour is needed? This sounds like just like the one we were just doing on yesterday's page. Okay, so it says step 1, rename the fractions by finding the least common denominators, like we've been doing. Then you're going to add the fractions and the whole numbers, or you could add the whole numbers, then the fractions. It doesn't really matter. We'll never know which one you did. And step 3, always, always, always in lowest terms. Always, always, always. That means reduce it. Make it as simple as possible. Sometimes they say simplify. Sometimes they say reduce. Sometimes they say rename. There's all sorts of different words to call it. But we want it to go down into the lowest. So something like 288, 600... I'm trying to make this easy. 44. We say, oh, look at that fraction. That's so huge. Well, let me do this. I'll make it faster. Okay, 280, 640. You can reduce it to this, which makes more sense, right? Our brains can handle that just a little bit better, but guess what? That can go down even more, because, let's see, 4 goes into both of those. Or let's see. I can divide both of those in half. 28 and a half is 14. 64 and a half is 32. Those can still go down even further, but this is a little bit easier to understand, right? These can still go down by 2's. Half of 2, 14 divided by 2 is 7. 32 divided by 2 is 16. And that's the lowest it'll go. So which one makes more sense to you? 280 640ths? Or 7/16. A pizza cut into 16 pieces, and you have 7 of them. That's easy to wrap your brain around. This one, yikes. Okay, so this is what we call reducing, or simplifying, or finding the answer in lowest terms. This is the lowest terms that this would go into, but all of these are equal to each other. It's just some of them are harder to understand than others. Okay, so once you get your answer, make sure you have it in lowest terms. So we've already done this. I feel like we didn't even need a lesson today, because we've already been doing this. All right, but I will help you with one of each of these problems on the front, and then we'll look at the back. So everyone look at problem number 1. We're adding and writing in lowest terms. Okay, as soon as Elmo focuses with us. Elmo. Wake up, Elmo. There we go. All right, so can 3 go into 6? Yes. Okay, don't forget to bring the moms across so you don't forget the whole numbers. Okay, then we're going to do 6. So put 6 on both of those. And 4 6 equals 4 6. So we like that. We can just bring that one across. So 2 and 4 6 equals 2 and 4 6, right? So what does 4 and 1/3 equal in sixths? Well, the 4 doesn't change. Now we do 3 times what to equal 6? 2. So do this times 2, which is 2. Now we can easily add because they're in the same denominator. Add the whole numbers. 4 plus 2 is 6. There's a lot of 6's in this answer. 2 6 plus 4 6, the denominator doesn't change, is 6. Look at that. Wow, 6 and 6 sixths. Try to say that fast 10 times. 6 and 6 6 6 and 6 6 6 6 and 6 6 6 and 6 6. Yeah. And now my mouth's all dry. Okay, so forget Mom for a second. She's watching you do your math. How much does 6 sixths equal? Think about it. You're thinking it equals 1, right? So take that, 1 plus the whole number, which is 7. And so our final answer we circle is 7. See? Easy. All right, then move down to the next section. They have a whole thing of explanation again, but guess what? It's exactly the same except we're subtracting. They're also showing you how to interesting how they did that. That's different than what we do in our other book. Let me pause for just a second. I wish I could pause that, but I can't. Oh, because it's in 6th. Oh, now I see. Okay. Crazy me. Okay, yeah. All right, so like if you get a question like this, you can do 4 minus 1, but you can't take 4 sixths away from 3 sixths. There's not enough there. So remember we talked about this before. You have to go to Sam's, and if they don't have all the pizza that you need, they're going to have to give one. They're going to have to cut up one more, right? So we're going to cut up one of the 4 pizzas, and if we cut up one of them, that leaves 3 pizzas left that are not cut yet, right? Okay, so that one that we cut up, we want it in sixths, so it matches this one. So if we cut a pizza up into sixths without giving any away, you would have 6 sixths, right? And this isn't just, this equals 1, right? So this equals the one that we took away. But it wasn't just 4 minus 1 and 4 6, it's 4 and 3 sixths. So you need to take the 6 sixths, which equals that 1, and add it to the 3 sixths. That's why they went like this and put a 9 there. Okay? And if I were you, I would rewrite the whole thing so you're not confused. We made that one into 3. It's no longer 4. And this is no longer 3 sixths. It's now 9 sixths. Okay? So write the whole thing there, and then bring this one just comes across because we're not changing anything with that one. A lot of kids don't want to have to do any extra work, so they don't want to have to write this out. But I'm telling you, you'll be glad you did because it will keep you from making so many mistakes, okay? So now we can do all of it. 3 minus 1 is 2. You see the answer? 9 sixths, we're not going to change it from 6. 9 sixths minus 4 6 equals, I don't have much room here to write it, do I? 5 sixths. So the answer is 2 and 5 sixths. Can we reduce that? Nope. They're right next to each other, so no. Okay, now let's look at the back. Don't forget to go out. All you have to do is 2 more problems in the subtraction section. All you have left to do is these 2 and these 2. Easy peasy. So now we're going to look at the back. The back is just like what we were doing yesterday. We're kind of putting it all together. You're going to add, subtract, write them in lowest terms. If they don't have the same denominators, you have to make new denominators. If you can't take away, like we just did, you may have to borrow. Like, for instance, number 15. Everyone go down to number 15. We can't just take that away from that. We're at Sam's. Whoops. We're at Sam's, and they have 5 whole pizzas that are not cut yet. And you want 2 whole pizzas plus 5 out of 6 of the other one. So they're going to have to do some cutting, aren't they? Okay, so we're going to take the 5. They're going to take 1 pizza. Okay, and we should probably do it up here like they said. 4. This would be a 4. And that 1 that we took away, we're going to cut up and make it into sixths. So what would 1 whole pizza equal in sixths? Because we need 4 plus 1 makes 5. 6 sixths. Good. So if the Sam's people take that 1 pizza and cut it up into sixths, you would have 6 sixths. Okay? So that's what that 1 equals. Okay? So this equals 1. 1 plus 4 is 5. So write this down here. 4 and 6 sixths, which is equal to 5, right? 5 equals 4 and 6 sixths, because that's 4 plus 1 pizzas, right? Bring this across. So now we have a nice little neat and tidy problem all together. 4 minus 2 is 2. 6 sixths, there's those 6 sixths again, minus 5 sixths equals 1 sixth. Can we reduce that? Nope. All finished. Okay? So that's on number 15. So if you don't have the right thing that you need to be able to subtract, you'll have to cut one of the pizzas up. Okay? So that section is really review. Pop down to the story problems, and I will help you with those. It says Lance has 10 pounds of plaster to make his volcano project. How much plaster will he have left if he uses 5 1/4 pounds? So he started off with 10 pounds, and he's going to use up 5 1/4. So we are going to subtract that. Okay? So he had to open that box of 10 pounds, and he had to use some of them. Okay? But he also didn't, he had like a partial pound left because he only needed 1/4 of one of those pounds. He didn't need the whole pound. So we're going to have to change 10 into 9 and an open box of another whole one would be 4/4, right? Because 9 plus 1 equals 10. It's kind of close together, but you get the idea. 9 and 4/4, and you're going to subtract 5 and 1/4. This is a really short, very close together problem. Okay, so now 9 minus 5 is 4. 4/4 minus 1/4 is 3/4. Right? Okay, so, and it's 4 3/4 boxes. Oh, no, it's 4 3/4 volcanoes. Oh, no, it's 4 3/4 plaster, right? Yes, but what kind, is plaster a measurement? No, 4 3/4 what of plaster? Pounds. Or you can do the abbreviation, which is different. It's the only one that we know of that you have to change it to LB for Libra. Okay, either one of those works. Okay, got that? Next story problem says the base of Lance's volcano project is a board that weighs 7 1/2 pounds. What is the weight of the base when the plaster is added? Uh-oh, I just erased that. How much? Okay, he used, took 5 1/4 away from 10. That was 4 3/4, correct? I believe, if I'm doing it right in my head, if I remember correctly, 4 3/4. Yes, okay. So the board itself weighs 7 1/2 pounds, and the plaster that he used weighed 4 3/4 pounds. So what's the weight of the whole project when you add the plaster to the base? So we're going to add here. Okay? So bring the whole numbers across. Okay? And can we add that together? Nope. So we have to make common denominators. All right. 4 and 2. Which one is 2 going to 4? Yes. So we're going to use fourths. So this one can just come across. 4 3/4 equals 4 3/4. Make this one into fourths though. Forget about mom for a second. 2 times what is 4? 2. So 1 times 2 is 2. Now we can add these up easily. 7 plus 4 is 11. 2/4 plus 3/4 is 5/4. Are we finished? Not this time we're not, because this is improper. Your mom says, hey, you're not sitting properly, fix that. So, how many fourths are in 5/4? We can do it this way, or we can do it in our brains. Our brain says 4 goes, there's 1 4 in there with 1 left over, right? So that would be 1 4 and part of a 4 left over. Or you could do it this way. 4 goes into 5 one time. 4 times 1 is 4. 5 minus 4 is 1. Denominator is the divisor. Divisor is the denominator. And the remainder is the numerator. So 1 and 1/4 is what 5/4 equals. We're thinking that. And now add 1 and 1/4 to 11. 1 and 1/4 plus 11 is 12 and 1/4. See why we have to circle our answers? Because look at all the mess we made while we were getting there. Okay, so 12 and 1/4, or you can also put it up here. 12 and 1/4 because you need a label. 12 and 1/4 what? We were measuring pounds, right? How much this weighs. So 12 and 1/4 pounds is our answer. Okay. Now, it says, John found this solution for the warm-up problem. There was a warm-up problem, and he came up with this. Do you agree with that answer or not? Over here, the question is, it must be wrong because it says, explain John's mistake. Solve to find the correct answer. Okay, so what did he do wrong? They both are in sixths, so you can add them together. What's wrong with this? Do you see it? Some of you see it. Do we add the denominators together? No. All right, so that should have been 7/6, right? Which equals something else. But let's first go and explain it. Explain John's mistake, sorry. Okay. John added the denominators together. Oops. Okay, so then it says solve to find the correct answer. So we came up with 7/6, which equals what? How many sixths? How many sixths are in 7? 1. 1 whole pizza in there. And how much left over? 1/6. 1's left over and 1/6. So it should be 1 and 1/6. Oh, it doesn't say. It's just a problem. Okay? And the bottom, oh, fun. The bottom is, oh, look, they even did it for us. I didn't notice that. 3/6 plus 4/5. That's what we did right here. Equals 7/6, which equals 1 and 1/6. Sorry, I didn't see that there. Okay. Again, if you didn't get that answer, rewind just a little bit and then pause it on the answer and you'll get the answer. All right, so number 20. These are missing numbers. We have to complete the equation. Sometimes let's see, are they all subtraction? They're addition and subtraction. So sometimes the minuend's missing, sometimes the subtrahend is missing, sometimes one of the addends are missing. Okay, so we kind of do the opposite. 2 minus this would equal this. So if we subtract this from this, we'll figure out what's missing. And that's what we took away from that. Okay? So if we took 2 minus 1 and 1/2, we'd have to cut up one of the pizzas and make it into halves, right? So 2 equals 1 and 2/2. So 1 minus 1 is nothing. 2/2 minus 1/2 is 1/2. So right here, if you were to subtract 1/2 from 2, it would leave you with 1/2. Think of it as apples. Okay, if you had 2 apples and a friend comes along and says, could I have part of your apple? and you just divided one of them in half and gave this piece to her, then you would have 1 1/2 left. See? Okay? Then 21 is, you know what, let's do this one while it's here. I was hoping to get them both in one box. Yeah, we can do that. All right, so again, you're subtracting this one. This time it's the, let's see, it's the minuend subtrahend difference, right? 12 is the minuend, minus 6 is the subtrahend, and the difference would be 6, right? Okay, so that time we needed the subtrahend. This time we need the minuend. And we're going to just add these together to get what it was to begin with. Okay, so 2 plus a third is 2 1/3. And then, like I said before, after you do it, don't just say, okay, we're done, and keep going. Stop and actually do your problem and see if it works out. 2 1/3, if you take away a third, it equals 2. See? So don't be happy with your answer until you've proved it. Make sure you know that that's the right answer by doing the math problem. Okay, 21 and 24. This one's easy. 3/4 plus, well, again, this is an addend. In order to get 1 whole, what do we have to add to 3/4? So either you can think of that in your head, or you can do this math problem. Okay, a lot of times we do the opposite to get the opposite operation, math operation, to get the right answer. So since the opposite of addition is subtraction, we'll subtract it out and it'll give you that number. So we got to cut that pizza up into fourths, which will be 4/4. 4/4 minus 3/4 is 1/4. Okay, now add this together. 3/4 plus 1/4, does it equal 1? It equals 4/4. See? Always stop and do your answer or do your problem afterwards and make sure you got it right. Okay, this one's easy because you're just going across, except the only difference is, okay, this is like the commutative property that we did way at the beginning of the year. So 1/3 plus 2/6 is the same as 2/6 plus 1/3, right? These two are the same, and these two are the same. You just flip them. See? Remember that? The commutative property. Okay, and then 22 and 25 are, let's see, 22 is not like that, but the 25 is. 22 is 3/6 plus what would equal 5. So 3 plus what is 5, because the 6 are going to stay the same, right? So 3 plus what equals 5? 2. Good. See, these are fun. They're easy too. Okay, this is another one of those commutative problems. So this one has these numbers grouped. Over here it has these numbers grouped. But they're still in the same order. 1/4 plus 2/4 plus 3/8. You're just making it look the same on both sides. See how easy that was? Easy peasy. So, another day of math under our belts. Good job, guys.